Okay, so for a section of gases, we have question 4. They say the graph that shows the relationship between pressure and temperature, and which one is correct. Okay, so the thing you need to think about immediately when you talk about gases is our ideal gas law. Okay, PV equals nRT. So in this one, they want to compare what's the pressure to the temperature. Remember, gases, temperature is always in Kelvin. So pressure to temperature, and they closed system, so that means the volume is constant, A gas is constant, and R is anyways the gas constant. So we're not comparing those. So P and T is on opposite sides of the equal sign. Both of them will be at the top of a fraction if we have a fraction. So they are equal, and then we said in grade 10, if it's equal, we can just as well say they are directly proportional, and that is your correct graph, and then option C will be your correct option. The next one is question 5, where they say that temperature has temperature in Kelvin has a set amount of gas. What is the new temperature if both the pressure and the volume increases by 2? Okay, it's doubled. So if we have pressure and temperature to increase, pressure and volume to increase, what will happen to the temperature? So number 5, we're comparing pressure and temperature, as well as then in another color we are comparing temperature and volume. Okay, so let's see the first one, volume and temperature. So both on opposite sides, so we can say that temperature and volume is equal or directly proportional. So as our volume increases by 2, because of the direct proportionality, then the temperature will increase by 2, thus change it to 2T. What will happen to the temperature if the pressure doubles? Again, pressure is directly proportional, opposite sides of the equal. So as our pressure increase by 2, what will happen then? Our temperature will increase by 2 as well, changing that to 2T. And then if we just multiply these two answers, 2 times 2 changes into 4T. So your correct option will be option D. Then our next question that we have on gases is question 7, where they give you the graph, and I copied it on the whiteboard, where they give you the graph of PV over RT, and you should know that that represents mole, over P, and they want you to go and check. They give you lines P, Q, and R, and they want to know which one is which. So this is our, there we have it. This is our ideal gas law graph, okay? So that straight line R is basically our ideal gas. And now we just need to go and compare the different gases. Now remember, ideal gas, they hypothesized that it doesn't have a volume or a mass, and it doesn't have a force, which is obviously incorrect, okay? So the only two gases that almost applies to the ideal gas law is helium and hydrogen, because they are so flippin' small. So helium will be the closest to be an ideal gas, so helium will be S, okay? But now we need to go and look at molecular masses and or intermolecular forces. So CH4, if we draw it, which is now difficult, if you go and draw the Lewis diagram for CH4, you'll see that it has a non-polar molecule, so it is London forces, okay? And NH3, because it has an N bound to a H, this is a hydrogen bond. So you should know that this deviation from the straight line, so this gap over here, okay, basically, well, not from that, from the straight line, the larger that deviation, the stronger the force will be, okay? Or the correct words that I want to use is the stronger the intermolecular force, the more the deviation will be, okay? So because CH4 has London forces, it's weaker forces, it doesn't have that strong deviation. So P should be our CH4, and then because NH3 has stronger forces, the deviation will be bigger to the ideal, so that is our NH3. That is gases.